Hello everyone. Today we will talk about some special right triangles. And these special right triangles are referred to as shortcuts. Specifically, we're talking about a 45, 45, 90 special right triangle shortcut. Something to note first and foremost is that this shortcut only works on isosceles right triangle. So please, as you're going through these problems, please make sure that you know for a certain fact that you are looking at a 45, 45, 90 or isosceles right triangle before you attempt to use this shortcut, okay? So do not assume anything. So with that being said, we know we have to work with an isosceles right triangle, but I have a square right here. This rule is based off of a square to start with because we know a few things about squares. First, we know that on a square, we have all of our sides that are congruent to each other. Second thing we know about a square is that we have 4 right angles. From here, if we draw a diagonal into our shape, so one corner to one corner, that splits our triangle directly in half. When people had gone through this over and over and over, they found out that if they used Pythagorean theorem repeatedly, that there is a relationship between the length of this diagonal, or the hypotenuse of our right triangle here, and the length of the sides. So our rule states that whatever this side length is, this side is the exact same length. And if we do Pythagorean theorem and simplify our radical, we will find that the length of this hypotenuse here is, again, that exact same length as our legs, but multiplied by the square root of 2. So that is our 45, 45, 90 special right triangle shortcut. Let's do some example problems so that you can see how those are applied. If we look down at example 1, we see that the legs are given to us. Both legs have a length of 3. And we know for a certain fact that it's a right triangle. So this is enough information to show that we have an isosceles right triangle. If we apply our theorem here, that means our hypotenuse also has a length of 3, but it's radical 2 times bigger. So the length of our hypotenuse here would be 3 times the square root of 2. In example 2, they give us the length of the hypotenuse as 10 times the square root of 2. So we really have to use our theorem backwards. Since the square root of 2 is being multiplied by 10, that means that our legs have to have a length of 10. Again, we know that this is an isosceles right triangle. We can apply these rules because we're showed that both sides are the same length, and we have the right angle symbol in there. Moving down to example 3, here we're told that we have a 45-degree angle and a right angle. That's enough information to prove that we have an isosceles right triangle. So if one leg has a length of 9, the other leg will have a length of 9, and our hypotenuse will have a length of 9 times the square root of 2. As we look at the practice down below here, please take a look at the 4 examples, and you need to solve for the missing side length. So I would pause the video right now, try these 4 problems, and then go ahead and hit play again when you're ready to see the solutions. So as you can see from these examples, we had 2 that we could go ahead and just apply our special right triangle rules, easy peasy. We got this triangle and this triangle here. We did get to use our 45, 45, 90 rule for our example down here, but we did have to do a little bit of calculations first before we could do that. This example over here was our trick